Welcome to week 6. This week is all about exponentials and logs. It's going to be a little tough. So let's start out with section 4.2, exponential functions. Basically, you want to be able to graph your generic exponential, y equals a to the x. Looks like this, if a is greater than 1. Notice that a to the x is always positive, and a to the negative x is just a reflection about the y-axis. And then you should be able to graph horizontal and vertical translations of these graphs, and that's what videos 1 through 6 is all about. There are no videos for the equations that you have to solve in this homework, so I wanted to just walk you through what's going on there. The instructions are, these are 2 examples from your homework. Use the one-to-one property of exponentials to solve the equations. Now, exponential functions are one-to-one. They pass the horizontal line test. And so what that means is if you have the same base, m to the a, and that's equal to m to the b, you can just say, oh, a equals b. Set the exponents equal. And so in this first example, if 7 to the 2x, I'll make this a little bigger so you can see it. If 7 to the 2x plus 1 is 7 to the x minus 4, well, they both have base 7. That means 2x plus 1 is equal to x minus 4. And so we can just solve that. Subtract x from both sides and then subtract 1 from both sides. X is negative 5. And you can plug that back in. Negative 5 times 2 is negative 10. Negative 10 plus 1 is negative 9. And here, negative 5 minus 4 is negative 9. Okay, the next one's a little more involved. We don't have the same base. 8 on one side, 16 on the other. But what 8 and 16 have in common is they are both powers of 2. So 8 is 2 cubed. And 16 is 2 to the 4th. Okay, now you use properties of exponents. If we have an exponent to an exponent, we multiply the exponents. 2 to the 3x plus 3 is 2 to the 4x minus 16. Now we're in the first case where we do have the same base. So I'm going to move up here and just set my exponents equal. 3x plus 3 is 4x minus 16. So I'm going to bring my x's over here, subtract x from both sides. So I have x on this side, add 16 to both sides, and I get x is 19. And there we go. So the homework problems in there aren't any more difficult than doing that. Section 4.3 talks about logarithms. Video 1 you should watch. It's a mini lesson on logarithms, what they are, and how to convert between exponential form of an equation and a logarithmic form of an equation. And it's, in a nutshell, it's right here. Log base a of x is y if and only if a to the y equals x. And so you can evaluate logs without a calculator, videos 2 through 6, by rewriting them as exponential equations. And he'll walk you through a bunch of examples there. And then you should know the difference between a common log and a natural log. Common log is log base 10. And when it's log base 10, we just write log x. We don't put the base 10 down there. And then natural log is log base e. And we just write ln x. 2 other things in this section. Properties of logs. Video 7. Now we're going to do properties of logs again next week, but this is just an introduction to the properties of logs and change of base. And so let me just walk you through. This is what the first thing I do in Calc 1. This is the first week we just review these formulas. Algebraic properties, and I do them all in terms of natural log, since when you take calculus, mostly you're going to be working with natural log. So this is ln x plus ln y. Log of a product is the sum of the logs. Log of a quotient is the difference of the logs, ln x minus ln y. Don't worry, this is all in your videos for this week. He uses different letters though. This r can come down as a coefficient. r ln x. But be careful, that has to be x to the r. It's not true if it's ln x to the r, where the whole log is being raised to the rth power. That r does not come down. So there's no property for that guy. Inverse properties of logarithms, logs and exponentials are inverses. I'm only going to state the inverse properties for natural log and e. So e to the ln x is x, and ln of e to the x is x. So exponentiating with base e undoes logarithm. Log undoes exponentiation. So for example, e to the ln, I don't know, root 5 is root 5. And we'll use this property later to solve harder equations. And also I'll do another one in the other direction. Ln of e to the 7 is 7. Change of base, I always change over to natural log. There's a general formula to change to any base, but I just go to natural log, ln x over ln a. So you have log base a of x, but you want a different log. So you just go ahead and take it. I want natural log of x. My correction factor is to divide by ln a. Why would you even need that? Suppose you're looking at your calculator right now and you're asked to evaluate log base 2 of 7. Well, on your calculator, you won't see a log base 2 button. You'll see natural log and common log, and that's it. So if you were to want to evaluate this on a calculator, you'd have to switch it over to either natural log or common log. I'd go to natural log. This is ln 7 over ln 2, and then you could punch those into your calculator. Okay, and finally, section 4.4, graphs and domains of logarithmic functions. So there are a bunch of videos that walk you through finding the graph of a logarithmic function. You should pretty much have burned in your memory that y equals ln x looks basically like this. It's got a vertical asymptote, which is the y-axis, and then it just goes up forever. And then you'll have to graph some vertical and horizontal shifts of that in your homework. It's domains that I want to talk about here. Your video has a slightly different way of showing you how to find the domain of a logarithmic function. I'm going to show you an alternate way. What I tell my students is if you want the domain of y equals ln of any function, okay, the domain will be found by setting f of x strictly greater than 0. Because look at the graph here of ln x. The domain is x greater than 0. You cannot take the logarithm of 0, and you can't take the log of a negative number. So if I put an f of x there, I need f of x to be positive. So if you wanted the domain, excuse me, of y equal ln of maybe 2x minus 5, okay, the domain, then the first thing you're going to do is say, well, I need 2x minus 5 to be greater than 0, and solve that. 2x greater than 5, x greater than 5 halves. So that's as an inequality, the domain, and as an interval, that would be 5 halves, parenthesis, comma, infinity. All right, have a great week and enjoy this information.